The following is a production of Frank DeFreitas and the Internet Webmuseum of Holography.
Hello, everyone. This is Frank DeFreitas, and welcome to HoloTalk for the week of May 10th, 1999. Our guest this week is Sam Savage, and Sam is lead engineer at Lucent Technology at Bell Labs. And Sam's going to come on and speak with us a little bit about how we can run these laser diodes and laser diode modules inexpensively without spending a lot of money on expensive power supplies to run these things. And not only inexpensively, but more importantly, now that we're able to do very beautiful holograms using these diodes, especially the higher powered ones, such as the recent test with the 35 milliwatt, but also consistent results. This is one of the things that running the diodes off the batteries has not been able to provide us, and that's consistent results. If you're running that, especially the higher powered ones where they're drawing more current, and you're running that diode for several hours to do a shot, well, when you get ready to do the second shot, you're not still putting the same amount of power into that diode, and your exposure time is going to change. It's very difficult to get consistent results if you're going to run these higher power diodes off of batteries, unlike the little laser pointers, which seem to run forever on the batteries. So what we're trying to do right now is get it to the point where we can inexpensively run them and get consistent results, which means you can leave that laser diode on 24 hours a day, and every shot that you do with it, you're going to have the same result and the same exposure time because you're still feeding the same amount of power in. Now, you can go out and buy a very expensive driver. I've seen them for over $1,000 to run these things, but we're looking at doing it for maybe about $20 or $30, where you can have that something that you can plug into the wall, run your higher power laser diode module off of, and forget about it. So Sam Savage is going to come on and give us a little bit of an idea on how to do that and where we are with that right now. Now, HoloTalk's getting ready to wind down for the season. If you know, this is our second season, and we run the same season that the television shows do. So we run from the fall until the spring, and when the TV shows go into their summer reruns, HoloTalk goes into its reruns as well. So we're looking at basically the last shows that are coming up. Now, next week is going to be a special show. I'm already thinking about some interesting things to do next year with HoloTalk, and one of the things that I've come up with is to do special holography broadcasts on the Internet to our overseas friends, such as Germany, Spain, Japan, South American countries, and a number of other different countries, but in their native language, so that their educators and their students at the schools or at home, if they have an Internet connection, they can log on and they can listen to a special broadcast specifically for them in their own language and learn about lasers and holograms in the process. It's sort of like a technological evangelism. So next week we're going to do the first broadcast in this series, and it's going to be going to Colombia, South America. And I met a student in one of my workshops that I ran over at the Science Center that I'm involved with over at Lehigh University. And I sat down and I spoke with him, and I asked him, would you come in and do some translations, and we'll do a special broadcast for your country. He's from Colombia. So we've got a press release ready. We're going to send that down to the major newspapers in Colombia, let them know through their media outlets that the students and educators, researchers, and the general population can log on and learn about lasers and holograms during a special broadcast in their native language along with English. So Andres Munoz will be in the studio with me translating what I'm saying into Spanish for our South American friends. And next year, I look forward to doing quite a few of these broadcasts. They won't be the regular weekly HoloTalk broadcasts after this first initial one next week. We'll have special pages for them to go to, and we'll just continue with our regular programming every week on the regular HoloTalk page. So I'm really looking forward to that as well. So let's move on to Sam Savage interview. Sam came into my studio for a workshop several months ago. He was very intrigued by creating holograms using the laser diodes, especially after a number of different people had told him it was impossible to do. And we've been working together, and Sam's been very helpful, working out power requirements for driving these diodes. As you may remember, I've tried a number of different experiments on my own, and they worked okay. Power supplies that drive the little Walkmans and things like that, and just running a laser module directly off of that. And some results turned out okay, some results didn't even turn out at all. But basically what's happening is Sam has come up with a way to provide very safe, controlled power that's inexpensive. And the whole point of this is to be able to be just working with these as easily as we work with a helium neon laser, which is plug it in the wall, turn it on, and work with it, and you pretty much have consistent results every time you're working with it, especially with the higher power diodes, because they really do pull a lot of current out of the batteries that we use, because I still used 3 1.5 volt AA batteries. But if I were to work with that and do another one later on in the evening, hours later, I'd have to adjust my exposure times because there's less power going into the module. So Sam's going to come on the show, and we're going to talk a little bit about power. And slowly but surely, we are working out every detail of making semiconductor holography a reality and a viable reality for making holograms. So here's a quick message from my studio, and after the message is over, we're going to go right into the interview with Sam Savage. So I will say thank you for tuning in, and I hope you tune in each and every week for the rest of the season. We probably have about 2 or 3 shows to go, and then we'll be on reruns for the summer, but we'll be back in the fall with brand new topics, brand new guests, and you can bet your bottom dollar some pretty exciting information to start off that first HoloTalk show in the fall. So I'll see you next week with our special broadcast to Colombia, South America.
Would you like to make your own one-of-a-kind hologram and learn how you can start making holograms on your own at the same time? You can do this and much more by attending one of Frank DeFreitas' holography workshops. From beginner to advanced, Frank's got a workshop that's just right for you. From single afternoon, evening, or weekend introductory workshops to Wednesday evening, 5-week complete courses. And don't forget his newest workshop, Laser Pointer Holography. Located just off the northeast extension of the Pennsylvania Turnpike and Interstate 78, the studio is a quick, non-stop drive from the New York, Philadelphia, and Baltimore, Washington, D.C. areas. For more information, call the studio's toll-free hotline at 1-800-458-3525 and begin your own journey with holography today. That's 1-800-458-3525 for more information on attending a Frank DeFreitas holography workshop today.
Hi, is this Ann?
Yes.
Hi, this is Frank DeFreitas. How are you?
Hi.
Happy Mother's Day.
Thank you.
Is Sam in today?
Yeah. Hold on a second. Hello, buddy.
Hi, Sam. How are you?
Pretty good, bud. Just resting a little bit. How you doing?
Okay. I thought we'd start off with just getting a little bit of information. And what's some of your thoughts about these diodes, and how can we run these diodes inexpensively without having to buy very expensive power supplies?
Well, if you supply the power to the diode that the diode requires, if you have a power supply that's supplying power to a battery to allow it to filter and delivering right potential to that diode, then it should be that should cut out the need for expensive drivers and stuff like that.
There's a couple different ways of running these laser diodes. Number one is just buy a raw diode and supply the necessary power at the exact specifications of the diode. And the other way is to buy the laser diode with the little micro driver inside and run it off of batteries. Do you see one advantage over the other?
Oh yeah, sure. If you buy the diode raw as it is and have a supply driving that, like with your batteries, the thing about using the diode and a power supply, the best thing is use a battery and keep the power supply on the battery.
I see.
Because the batteries, you may, after a while, may fluctuate. You know, the voltage may drop, but it will over time. But with a battery and a power supply, which doesn't have to be that expensive. A cheap power supply on a battery, allowing the battery to filter out that supply with any kind of noise that it may be coming from the power supply. So that'll filter it, and that way it's a lot cheaper than if you bought a driver and everything else, and he syncs with the driver and all that. Well, that can amount to a little bit of money, you know.
Yeah.
But still keeping it way below what would cost for a Healy or any other gas laser.
Yeah. Now, the battery acts as a pretty good filter then, right?
The battery is an excellent filter. You can look at a battery as you would look at an electrolytic capacitor, okay, and that which will be a filter all the time on the battery would be completely still a much better filter than an electrolytic capacitor. Mm-hmm. But theoretically, you can look at the battery as an electrolytic capacitor in the sense of filtering, okay? Mm-hmm. But the electrolytic capacitor characteristically is the same as the battery. In other words, if you have a electrolytic capacitor that its working voltage is, say, 75 volts, but you're only going to put it across 6 volts, 4 volts, or 5 volts, or 3 volts, it's going to charge up to 3 volts, although it's got a working capacity of 75. Mm-hmm. Okay, it would do the same work at 3 volts that it would at 75 volts. The properties of that capacitor would do the same thing that would at a lower voltage. Now, you wouldn't go above that voltage, 75 volts, but that would damage the capacitor. Mm-hmm. And so the same is with the battery. And looking at the electrolytic, looking at the same as electrolytic capacitor, the battery will do the same thing. Now, it does not mean that you can that you have to charge a battery if it's 12 volts or 6 volts. You don't have to charge it at that rate. If you got a 6-volt battery, say like a lead acid cell battery is really good for filtering and keeping a good charge. So if you have a 12-volt battery, the short is saying electrolytic is 75 volts. In other words, you don't have to charge the 12-volt battery at 12 volts. Mm-hmm. Okay. You don't want to go above that or over its threshold, but you can go below that. Mm-hmm. And it will maintain its charge at the voltage you're charging at, and you have a lot of capacity there. And best thing of all, you have the filtering that you need. If you've got a power supply, if you have a power supply that's linear instead of switching. Yeah. Although if you do have a switching power supply, the battery will filter. But I don't think I would take a chance with it on a raw diode. Yeah.
But supplying one of the modules, it would be.
Oh yeah, it'll be fine. Yeah.
Now here's a little idea I have. We have the 35 milliwatt diode module that we've been running. I did the holograms off of the module at 4.5 volts. So if I went out and I got a 6-volt battery, and I drained that battery down so it was below the 6 volts, actually below 4.5. And then I got one of the inexpensive chargers that you can get for running Walkmans and send that into that battery at 4.5 volts. And then run the module off of that battery, we'd be in pretty good shape.
Yeah, you would. You can charge, let's say you're saying you needed 4.5 for the driver. Mm-hmm. Well, I would charge the battery a little bit more than 4.5 because you're going to have a drop. You have to take care of the drop where it maintains 4.5. Okay. Now, I'd go up another at least half volt and charge it that way. And that way, that would float at the level you want it to float at. It's like you want to let it float at 4.5. That's what it'll do. Mm-hmm. And it'll maintain that and also take care of the filtering that you need.
Now, could that charger be left on that battery continuously?
Sure. Now, we try to do this real simple. We don't get into a lot of theory and all this other for people to understand. But if you have a 6-volt battery, mm-hmm. okay, and what you could do is put a 6-volt lamp, the bulb, in series with that charger and the battery. You can notice the lamp, it will be real bright if it's low charge. As the battery begins to charge, the light will go dimmer and dimmer. It means there's no current being pulled from the charger to the battery.
I see.
And when it gets almost out, it will, you could say it's charged.
Mm-hmm. Now, would you leave the charger on there or take it off?
I would leave it on because you also have in there, you can always watch it. The lamp will also protect it too.
Yeah.
Okay, so you can monitor the how your battery's doing by just looking at the lamp, 6-volt lamp.
If you wanted to charge that battery at 4.5 volts, you'd get a 4.5 volt lamp, right?
Well, you don't. No, you can get you can still go with 6. It'll still fire to 6 volt, but it won't be as bright.
I see. Okay.
As long as you got current flowing through there, that's still going to be that with 6 volts. Yeah, that was still, you still get some light from that.
Now, in essence, what the battery's going to do is it's going to filter out any noise that's coming from the AC line, right?
Any noise that's not been power supply that's not filtered, after it goes through, AC goes through your power supply, then you know what it's going to do. The transformer, you're either going to step it up or step it down. In this case, you'll be stepping it down. Then it's going to be, go through a bridge rectifier in most cases. The rectifier is going to be changing that AC to pulsating DC. Now, we're not pure DC yet, okay?
Mm-hmm.
And if your power supply's got filters in there, that's going to smooth out the best it can the pulsating DC. That's changing from AC to DC, but it's actually changing from AC to pulsating DC. Now, a pulsating DC without being filtered to any kind of circuit is AC. So the pulsation is absorbed by the output capacitors in your power supply. Now, if any noise gets by that, if there's still some ripple pulsations in that DC, well, then the battery will take care of it.
So it's a very good filter.
It's an outstanding filter.
And any type of spikes that would come through the AC line, or any types of slight variations, like if someone in the neighborhood turns their air conditioner on or the refrigerator kicks on and off, the battery, the diode running off of that 6-volt battery charged at 4.5 volts will actually take all that out as well.
Right, it should filter out the output. Because the AC fluctuates and changes, well, that means your DC is going to change. Unless your power supply is regulated, how they regulate it. I mean, if it's regulated, that means it's not going to go above what you need, okay?
Okay.
But if it's not very good regulated, then you get spikes. Well, yeah, spike is going to get out through on the outside the power supply.
Yeah.
But that spike or dip is going to be absorbed by the battery.
Now, how would someone hook this up? Let's say I have one of the AC to DC converters that we run the Walkmans off of, so one of those that you can buy over at Best Buy or other electronic or stereo store to run your cassette decks or portable Walkmans. And they have the different adjustments for 3 volts, 4.5 volts, 9 volts. So let's say we buy one of those. They're relatively inexpensive, maybe about $10. We set that to 4.5 volts. We've got our 6-volt battery, and we want to put the 4.5 volts into the 6-volt battery, and we want to run the module off of the battery. Do we just take the wires and attach it to the battery, and then take the wires from the module and also attach that to the battery?
Sure. You take your power supply and put it across your batteries.
Yeah.
Okay. You come
to the terminals.
Yeah. Off the same terminals and go to your module. So that's just it. What you're doing, you're looking at it as a filter, output filter.
Yes.
Is what that battery is. What you're.
Yeah, it's acting more as
is looking at as output filter.
Yeah, it's actually acting more as a filter than it is the supply.
Right.
Power.
You're not really the batteries. One reason the main reason batteries are used in an electronic circuit, it's not just for reserve power, but it's for filtration.
Oh, I see.
If you got a circuit that it acts as a filter and acts as a battery as a backup in case you lose an AC failure or something.
Mm-hmm.
So they're sitting on line. Now, some circuits depend on how much load you have, and the batteries may not be be sitting in a circuit as a reserve, not cut in.
Yeah.
Until you get a low voltage disconnect, until you get a power outage, and then the batteries cut in.
Mm-hmm.
But most cases, the batteries are sitting on the line, on the output of the line, the power supply, sitting there charging and filtering. Because the fluctuations in the AC, and if you have an inductive load, okay, an inductive load, that will take care of the noise that may be coming from equipment. Some of the equipment can cause, your load equipment can cause noise, and also it would filter that out.
So this is looking pretty good and very inexpensive as well.
Well, we got the whole. We can get into talk about some real elaborate regulated and all this stuff, drivers. But we want to, since we've gone to the diode and not dealing with helium neons anymore, expensive way of doing holograms, if we're going to go to trying to make this thing as inexpensive as we can, well, then everything has to be inexpensive.
Yeah.
And we have to make it these inexpensive diodes. Well, we got to, make inexpensive power supplies if everybody wants to be able to do it. You can go as elaborate as you want to, and it's like you can go just expensive you want to get, but we can do something that's cheap that will do the job. Well, I think that's the route we ought to try to go.
Absolutely, and it's always, you can always run the diode module off of regular AA batteries or whatever, but the only problem with that is the longer that diode's on, the less voltage is going into it, and you're getting less power as time goes on. And
that could affect the diode, depending on the diode. That diode, the battery at let's say that the battery let's say the current drain, the load of a 35 milliwatt laser diode is set at 45 milliamps. Well, then it won't take long, too long for that. If you just put the battery on it without keeping it floating, the voltage is going to drop.
Yeah.
And like the 500 milliwatt, that was around over 1,000 milliamps, because you're talking about 1 amp.
Yeah.
So on a battery that ain't going to last long at all. I mean that's going to drop. And that won't be enough for the diode, and that could cause heating problem with the diode. On the 5 milliwatt, there's no problem. Okay, it had a pretty good range there on that 5 milliwatt corner.
Yeah.
Had a pretty good range. You could run a good while, and I noticed you charging yours with a solar cell.
Yeah.
So, but when you start getting up into more power on a diode, increasing as we go on up in power, well, that's I square R, and that's or E times I. That's going to be more watts. It's going to be more current pulling. It's going to require more current to operate, and that's why it's a good idea to have a battery with a charger sitting on it, and preferably the lead acid cell.
Like a lawnmower battery.
Yeah, it's one that's a lead acid.
Yeah, I'm not sure about motorcycle batteries. I'm not sure if they're 12 volts or 6 volt, but I think the lawnmower batteries are like 6 volt.
Well, I think you can buy these lead acid cells. There's pretty good amp hours on it, and at 2 volts. And used to be maybe you can buy some that's at 1.5 volts a cell. And then you have a lot to deal with. You play with. So they're lead acid, a lot of capacity, and not that expensive. So there's some places around to have that you can get these. I know Gates makes a lead acid cell about 3 inches in diameter. About 6 inches high or something like that. It's got pretty good capacity, and it's lead acid. And you can string them up to the voltage that you need and put your charge across it.
And if you wind up with more voltage than you need, you can just
you can just drop it. You just drop. Figure out your voltage drop, the voltage you need. Figure that voltage drop, then you determine that from your the amount of current it's going to be using, and then you can determine with Ohm's law what kind of resistance you need to drop that voltage.
And just put a resistor right in line there.
Right, exactly.
Yeah. Well, it seems pretty easy. And why go out? Because I've seen some of the power supplies for the diodes that are running over $1,000.
Well, absolutely. The drivers sometimes they are very expensive, but I believe we can do it a lot cheaper. We made it so inexpensive, especially with your shoebox photography. I mean, my goodness. And we dropped it. The cost has come way down. What it used a long time what it used to be. We making history and making pioneers. So we might as well make the power supply along with the diodes. Make it all cheap so people will be able to do it.
Yeah. You have that hologram of the angel now. What do you think of that?
That thing's that is actually breathtaking to know that was taken with a 35 milliwatt diode, and a helium neon couldn't do as good a job as that. It's really unbelievable. Actually, I know it's hard for folks to see that on the internet on a picture after you've taken a picture of it, but actually seeing this hologram, it's actually breathtaking. It's unbelievable, the depth with the wings and all that. It's just unbelievable. And it's real bright. It's an amazing thing too. It's real bright. It's amazing. It really is amazing.
Well, Sam, I want to thank you for taking the time today to come on the show. And don't forget to log on tonight. It'll be on by midnight tonight, which is Sunday, and I'll be talking with you, I guess, a little bit later in the week.
Thank you very much, Ray. I'm glad to be able to. I'm not too good at this talking, so special ideas, but thanks for having me on.
All right, Sam.
Bye.
Talk to you later.